In this video, we're going to determine a way to calculate the volume of a sphere, much in the same way that they did many, many years ago, prior to the advent of both calculators and computers. For this, what we're really going to do is look and say, okay, we have a sphere of some sort, and then we have just a little box here. The entire sphere is made up of all of these little boxes right here, and they all converge to a point. Okay? But this is just a rectangular pyramid, okay? Something which we know the volume for. Recall, the volume for a rectangular prism, or I'm sorry, a rectangular pyramid is 1/3 of the value for the prism. So 1/3 your height times your base area. Okay? But recall, if all we're doing is saying that the entire sphere is made up of all of these guys, they all have the same height. The height itself is the radius of the sphere. Okay? And what's the base area? Well, remember, it's the base area of this guy plus the next square, the next square, the next square. All of these squares added together ends up being the surface area of the sphere. Okay? Because you are taking 1/3, h is now the radius of the sphere, times the base area of 1 plus 1/3 r, the base area of the second one, so on and so forth. You're adding them all together. So what you're really doing is writing 1/3 of the radius times base 1 plus base 2 plus base 3. If you add up all of these squares, all you're going to get is the total surface area. Okay? So we already know that the surface area of a sphere is equal to 4 pi r squared. Okay? So then, therefore, what do we have for the total volume of the sphere? The volume is 1/3 r, 4 pi r squared, 1/3 4 pi r cubed, or 4/3 pi r cubed as the volume of a sphere. Okay? Now this is not a definitive derivation of this. It assumes quite a few things, like that square is actually flat. Well, we know in a circle or in a sphere that thing actually has some bit of curvature to it. It's not just a flat piece, it has some curvature. So we would have to actually account for all of these things, or at least say what those assumptions really were. But this is one way to visualize, okay, how do you find the volume? This is very similar to doing the subdivision methods, just with volume instead. We are taking a full sphere and breaking it up into tiny, tiny pyramids.